compare network hardware. So let's continue. We actually done with 4B, so I think we are in 4C. Okay, so let's move straight to 4C. Okay, 4C. So now we're going to look at cable types, explain network cable types. So this is where we're going to continue from. So we look at 4A, 4B, now 4C, explain network cable types. Okay, let's go. So these are the network cables, that we talked about earlier. We'll talk about networking and we'll talk about network cables. So these are network cables. So the most popular cable is what called the twisted pair and the untwisted pair cable. So most of our network cable we see, we actually call them Cat 5 cable, Cat 6 cable, which is category 6, category 5 cable. So that Cat 5 cable or that Cat 6 cable, is usually made of two types. So we call it unshielded twisted pair and shielded twisted pair. So when you say unshielded twisted pair, you use network cables like this. So the network cable has pairs of cable inside. You see, there are actually four pairs of cables, one, two, three, four, made of eight wires. Right? So you see four cables made of eight wires inside. So each of them carries electrical signal. So this is actually what we use in our network. This is the insulator jack that, of course, this is the wire twisted pair. So that four pair, right? So we have to understand that this kind of network cable, is a what is commonly used on shielded twisted pair. So it's not really protected. It's not a protected network cable. So if you use the network cable, it can allow for network interference. So, like, if you have electrical appliances, electrical devices around the building, if you have electrical cables run in the same direction with this cable, so you're going to have electrical interference with this kind of cable. And aside that too, it's also the signal drops, which is attenuation. So the signal tends to attenuate. So attenuation is the rate at which signal reduces as it travels. So this kind of cable can actually go more than 100 meters. This kind of untwisted pair cable, it cannot go for more than 80 meters, right? 100 meters rather. So that means if you have a computer in your office and you have a computer in another office, or maybe you have your switch panel in another office. So I need to draw a cable from your office to that office where you are. It means that this kind of situation, you ensure that where you are drawing the cable to from your computer to wherever you are drawing to, the cable must not exceed 100 meters, or else the signal will start deteriorating. Now, there's a device called a repeater that we used to boost network signals. We used to boost when signal when at the time the signal gets to 100 meter, you can put a repeater there to boost it to amplify the data to regenerate the signal. So that's the way you can actually regulate signal. Or else, as soon as the cable gets to 100 meters, the signal start dropping from 100 meters, right? So this is a two-step pair cable. So this is one of the cables you're going to see in networking. It's called unshielded twisted pair. Unshielded because it's not protected. Now, take a look at the next cable now, which is shielded. See, take a look at it. This is shielded twisted pair. So compare this now with this. See the difference. For this now, you notice that what this after this, insulator jacket, there's nothing protecting these wires. And compare this. Look at the shielded twisted pair. So now there's a cable there's also there's a after this the main insulator. There's another like a copper, that protects your main. Look at your main wires, your main two-step pair. Look at them, your main wires. See the four pairs of wire we'll talk about it. So there's something protecting them. Now in this kind of scenario, it protects what electrical interference, unlike the previous one. Now for the previous one, where you have a fire, the previous on Tuesday spec where you have fire, this cable can just melt up. Electrical spark can just melt them up. Apart from that, domestic animals, like rats, you can just eat them up. But for the shielded twisted pair, this shielded twisted pair is not going to be easy for electrical interference to happen. Aside that, it's going to be very difficult for fire to burn them up, but it has what outside the insulator, there's an internal protection on the wires. So these cables they can go as more than 185 meters. These are untwisted pair cables, so they're well protected. They don't have as much 185 meters, even up to 200 meters before the signal start dropping. So if you want to ask me what's the best cable to use in a place where you have electrical wires, where you have a conduit, where you have a factory, these are kind of these are kind of wire you use to protect against electrical interference. Where you have for where you have factories and ions and the rest metal there. This kind of cable you're going to use, that protect electrical interferences. Okay, so and also for fires instance, it also protect against fire, so it doesn't get burnt like that. So this kind of cable we talk about. So this is far better than the unshielded system pair. Now the shielded system pair also, like I told you, it carries what? It travels a longer distance than unshielded. It can go for as much as what 200 meters compared to your unshielded that can go for 100 meters, right? So take a look now. So we talk about the cat. We call it cat five, the cat cable. So you call it category standard. That's what cat category standard. So you have category 5 is 6 and 6A. So each of these cables, so back then it used to be Cat 5 that goes for 100 meters, then Cat 5A. But now most of the cables that we see now are Cat 6, some even Cat 6A. So it just tells you about the distance they can go, right? This is maximum distance. Look at the maximum distance they can go. For Cat 6A, these are Cat 5, these are distance they can go. And what the maximum rate of data transfer, which means how often when you're transferring data, what is the speed of data transfer? At speed your transfer is going to be. So you're trying to maybe you're trying to access another computer. So how fast is going to look like for you to access another computer? You're trying to transfer data. What is the fast? You're trying to download and all these things you're doing with that network cable. So how fast is it going to be to access data? So that's what called the maximum transfer rate. So for category 6, you can have category 6 that can transfer for 1 gigabyte per second. You can have that can transfer 10 gigabyte per second. For Cat 6A, you just have just one 10 gigabyte per second, no 1 gigabyte. Then these are the distance which you can go. So if you are going to use category 6, so just be sure that you have between 100 meters and 55 meters. So you have to be sure you're buying. So if you're going to buy 10 gigabytes, you have to opt for the one of Cat 6. You have to opt for one that can go for what 55 meters, right? So that is the maximum distance. Or if you are going for 1 gigabyte, you have to opt. So which means it's going to give you 100 sorry 100 meter, I'm sorry, for 10 gigabytes can give 55 meters, right? Why for 1 gigabyte gives you what 1 meter. So what's it telling us? It's telling us that the higher the distance, right, the lower the speed. See, the higher the distance, the lower. So yeah, we can go for 100 meter meters per that's the distance 100 meters. But this that means 100 meters, the distance is far, but cannot exceed what 1 gigabyte per second. So same with category 6A. So category 6A have a 100 meters that can go for as well 10 gigabyte per second. Okay, so that's that. Okay, so now the next thing we'll talk about now, very important. So this time I need to pay attention to some explanation here, right? So this what you have here now, you're going to see what we have here now. For this now, this is what we call RG45 connector. See? So your network cable, your category 5 cable, maybe shielded or unshielded, right? That you have, you're going to terminate it. So there's a jack called what? RG45 connector. I don't have it here. You can go online, just go take a look at it. RG45 connector. So that connector is just a modular, all right? That's it look like. See, modular like this. So that connector will go into a jack, a wall jack called RG45 connector. So this is a connector, RG45 port. Is a port that this one will go into too. So now is when you set up your cable, all right, you set up your network, all those wires, you set it up, your network, you set it up. When you set it up, it has to go into this ports. So your computer devices now that you have, your system device, the network card you have in your computer, the one end will go into one end of the cable, this cable with this connector will go into your computer device, while the other end will go into the wall socket that will eventually get to what the switches, right? Okay. So the next thing we have here now, they are connectors. See, they are wires. So if you take a look earlier, we showed you about those. We showed you about this. See, take a look about these wires. See, all these wires. See, we have orange, green. We have green. So we have orange, orange, white. We have green, green, white. We have brown, brown, white. Then we have blue and blue, white. So all these see now, all these colors, they have a way to set it up in a way that you can actually they can actually go to transmit and receive signal. If you don't set it up in the right way, just so you are there, we call it what cable configuration. If you don't configure the cable very well, data will not be transmitted. She puts blue in where she should have green, and you alternate it. It's not going to work. So there's a standard way, that is me what set how they can be configured. So the standard way is what we see here. This is standard way. So now we have two standards. So one end, look at it, 5 6. See, 5 6, it's a standard. There were 5 6 8 be standard. So what you're saying is that if you have a network configuration, again, like I told you, I'm going to do a special training on network essential where we explain so many things. So you need to keep up following us after the whole of CompTIA A plus training. So we're still core one. After core one, we're going to move to core two. So after core two, so I will spend time to talk about network essential. Where I can explain more about straight cable, crossover cable, when to use them. But for now, we just have to follow, this one. Because A plus actually expects you to have known about network essential before you come into A plus. So that's why they didn't spend time to talk about them. But I'm going to talk about them in a separate class after the end of the training. So watch out for our video on network essentials. Okay, so now here we go now. So for this now, you see, so it's your network cable, your Cat5 cable that you're going to use. One end, right? One end will have this configuration. See, 5 6 8 standard. So now see one end will have green, white, green, orange, white, orange. See, just follow the WIS method to assemble them. In that video, I'm going to teach you about network essential. I'm going to have the I'm going to have the I have all the tools ready for you. You can try how to set up the cable, how to crinkle them, everything. I'm going to have everything ready for you that you're going to see. Right? Okay. So just follow this pattern. Follow this pattern from A. So one end of the cable have this setup of configuration. You see, one end will have this one. Another end of the cable have this. So both ends. So which means one end here and the other end that will go into the socket will have this one. So the first end A will go with this, B will go with this. So that's how you're going to set it up. So one go to your network computer, one go to your network device, which is your computer. The other end goes to the wall socket or your switch. So that's how it is. So both ends must not be the same, right? For this kind of connection. So there's a time whereby we're going to have both ends the same. We can have both ends the same. Which means when you have this kind of cable now, you see, they're not the same, right? Normally, in this kind of configuration, they're not the same. It means that these cables, they are what called cross cable. So when you have a network A and B, right? A and B, usually, it means that you don't have a cross cable. So a cross cable configuration means that both ends of the cable will not be similar. Won't be A and B. Now, for this one that we explained earlier, I'm just explaining to you. Now, in a real scenario, in a real life scenario, right? If you want to connect your computer to your network, uh, both ends of your cable configuration must be what one. So in other words, this A, if you are using the A standard, one side of the cable connection configuration we have this connection. The other end we have same A, so both sides have to be A for you to be able to connect your computer to your network. Now, wherever you have when you have both, when you have this one standard as A and that one as B, now is this kind of configuration. You just want to connect two similar devices, two similar, like this. You want to join two switches together, you want to do paired network together, two computers only. You can do that. You want to connect two same devices or two switches together. You want to join two switches together. You can do that. Two routers together. You can do that. I'm going to spend time to explain all these things in network essential class. So don't miss that video, right? So just understand now that this one now, for this cable, know the standard because you're going to see in your A plus exam. Know this one that your copper cable connectors have these two types. 5 6 A EIA/TIA 5 6 8 A standard, EIA/TIA 5 6 8 B standard. So this is what you're going to have. So they're actually 8 pins with 4 wires, right? So these are the standards. So take note of them. We move on. Okay, so practically now, this is how you set up the cable structure. So we have a punch, we have a crimping tool. So this is what I'm going to use. I'm going to practicalize them everything for you, subsequently. So when we talk about that network session class, I'm going to show you how to do them practical, how to set up all these things so that you can be able to do it by yourself. So watch out, like I said, watch out towards the by the end of the A plus training. I want to have a special session where I will talk about all these things. I will talk about network essential, how to set up computers, put up your addresses, make contact, talk to each other, how they can communicate. I'm going to show you all those ones practically. Okay, continuation. So now this is a punch down tool. So for this now, for this kind of so this is, see, this is a cable now. So this what you see now, this connector what you see now, this connector, you see, this is what goes to the wall. So if you see a cable, if you when you connect a network cable now for a computer, they connect to the wall. This is connector, they connect it to this connector. That way it goes to the wall. Inside, that's how it looks like. So you just follow the color configuration, the color mode. You follow the color mode. Where there is blue, they put blue. Where there is green, they put green. Where there is blue, white. You just follow it. You see it on the connector. Just then you have the punch and put it and press it. You don't clip. Now this crimping tool just to the crimping tool just to press your as far as you connect the connector inside. You have to use something to crimp it to make sure that you can go in. So that was the crimping tool. We're going to practicalize it, right? We're going to practicalize. So don't need to worry, right? So now we also all these are form of cables, right? Cable tester, toner probe. For cable tester, once you set up both cables, you set up both cables. So what you need to do is to verify that they are working. How do you verify? If I set up the both cables now, I need to verify that they're both working. How do I verify they're working? I use the network cable. So that means I set up the two cables at one end. So look at it now. See, look at what happens. You see, these are the two cables. One cable with one end and another end here. So you can test it using the cable tester. So just put one end of the cable on your tester. This is called we call this cable tester, which is that's called LAN tester, network tester. Put one end of the cable there, put the other end of the cable, then you just on it and watch. It's going to show you one, two, up to eight. So if any of the line numbers are missing, it means that that number of that cable is not working. Maybe wire 8 is blue, it's not working. Or wire 5, 4 is green, it's not working. That was not, so you're going to miss it. You're going to jump down, which means that line is not working. But if it goes to 1 to all to 8, means you have an excellent configuration, right? So then what about toner probe? Toner probe is just a trace cable. So if you have a long network, your network is the distance to where you have the switch is very long. So you're trying to find that you trying which cable goes to the switch. You want to find that. So you can use your tracing cable, a toner probe to trace the cable. So I can know this cable is connected to this port and on like that. Your loop back plug just the ports, where you connect your jack, your RJ45 connector, that port, on the switch port, it's called loop back plug. Where you plug the cable on your network card too, that I showed you earlier, just connect it. You call them loop back plug. Where you connect your network cable too. We call them what? Loop back plug. So you look at the test NIC or switch port. So that way you connect your network cable to on the switch and the what network card. So earlier we talked about NIC, network interface card. This is network card, right? Okay. Let's continue. So we have some interesting things here that we just have to go through. Very interesting. So we have what we call capture network traffic. So usually, in networking, especially for those of us that are doing cybersecurity, you can capture your network traffic. So you want to see all the traffic coming in, all the traffic going out. Who is accessing your network, how they access your network, who device they are using, what address are they using, which location are they coming from? Are they coming from US? What time, which geographic part of the world they are. So you want to know everything. What OS are they using? You can do the trace all these things through a network what capture. So you can capture the network. So that usually have a network monitoring software program that we can use to capture traffic. So you can see everything coming to your network, go in and out. You can monitor it. So that is for network traffic, right? So now we also have what called test access points. A test access point. So a test access point is similar to capture network traffic, right? So in a capture network traffic, it could be either you are doing through a software to capture your traffic or you have a hardware. So a test access point is similar like this one. So now this time you have a hardware device. So you look at, okay, just see what you have. See, is a hardware device used in IT and telecom to monitor and copy network data without disrupting a live connection. So you're trying to monitor your data connection. You're trying to monitor it. What is going coming. You're trying to monitor it. You want to see, you have the place. You have a device that can go to copy the data and monitor the traffic without disrupting your networking. So that is what called test access point. We also have the passive and the active words test access point. Right? What the passive one is just a hardware devices that can use to monitor the traffic by creating complete or interactive copy of the data flowing. So we call it the passive one. So you have the hardware device that does that. The active one is the active one. The passive. Okay, let's take it again. The passive network access point is a hardware device used to monitor network traffic by creating a complete uninterrupted copy of the data flowing between 2 points without altering or dropping the packet. So this is just interrupting, is a hard advice to monitor traffic by creating so you just want to monitor what's going on, create a complete copy of data flowing from between 2 points. Now, whereas for the active one, it's just active one just for you to have a two switch for instance. In the two switch, you could have this asset active assets connected to two of them. See, it says it's an inline hardware device that duplicates and split network traffic for analysis, security, and monitoring. So what it does now is just to have a device in between your two switches. Have device between inline. So what it does, that device will now be splitting the network traffic, will split it into duplicate part of it, so that you can be able to analyze and monitor what's going on. A mirror port is just simply um, a mirror port, just simply a way to duplicate network traffic and send it to what a destination port on your switch. Again, you want to duplicate your network traffic, you duplicate them. Then when you duplicate them, you now send to a specific port on your switch. So we can call it the switch port analyzer. That's the mirror port. So it's the external port on your switch. So that port will now be to analyze those traffic. So that we call a mirror port. Okay, so let's continue. So we have cabling. So yeah, now it's all about. We don't need to spend much time about this. We don't talk spend time. This is about cable installation. So for instance, those cable you see outside your premise. So how they so copper the like fiber optic cable, you see them outside your premise and stuff like that. Then of course we also have some cables too in your buildings, right? For instance, in your building you have like what we have now installation of platinum. So platinum usually are enclosed area in a building whereby you want to create ventilation air, like what you have here now. See, heating, ventilation, and air conditioning. So a place where you can, like this building I have now, I can create a space whereby air can be going out, right? Air can be going out. So there's a specific cable, a cable you have to use. So we call it plenum rated cable, which you have to use for that, so that they can take air for heat, to create to absorb the heat and ventilate, so that everything can work going, even for air conditioning too. So there's a specific kind of cable for that. They also have also installation has outside plants too. So outside the building too, like ISP's cable, how they are being set up, using the fiber optic cable, where they have the fiber optic cable, they have a switch box outside, where all the cables are coming in. So you don't need to bother so much about these things. Some of these things are not actually necessary, but you just know them. They're not necessary for you. So most of these things are being done by electrical engineers. So for this one, it's done by the ISP engineer. So you don't need to bother so much about them, right? But just have an idea. So let's continue. Okay, so fiber optic cable, right? So these are fiber optic cable that is usually used in by ISPs. So fiber optic cables, they're like this. So you go to see fiber optic cables, these are fiber optic cables, and these are the connectors that they are used. ST, ST, and subscriber and line Lucent connect. So again, don't bother so much about this, about fiber optic cable. Just the fiber optic cable is the fastest cable. You can see that it's the fastest cable and has the ST and ST connector, SC and LC connector that I can use. So second, these are the unlike your cartridge, these are the setup. If I your fiber, these are the the loose end of fiber optic cable. When you lose it, you're going to see these are how fiber optic cable are. You understand? So they're the fastest. It can go as fast as light, very fast. So the fastest, form of data transmission. So most of these ISP they use fiber optic cable. So fiber optic cable are those ones that go through underground waters. They carry huge amount of data. That's what they carry. So that is for fiber optic cable. So we also have another kind of cable called the quasar cable. So the quasar cable are those kind of cables that we can see on our television sets. So those cables they used to connect TVs and the rest. Back then we use most back then for TVs. So you have an antenna outside, you want to use a cable, just connect your fiber optic cable to it, and stuff. So the house now that connector called the F-type connector. So these are typical examples of fiber optic cable. This is it. Okay, so there we go. So now we move straight to 4D, compare wireless networking types. Very important. We're going to be very fast. So 4D, so we have an access point. Now, for us in networking, we have to understand that wireless network has its own standard, right? So for a wireless network, we said earlier that a wireless network falls into a standard called IEEE 802.11. So that is why the wireless network falls in the standard. That what it falls into. So in that wireless network, it has no infrastructure. My infrastructure devices, its own way of connection. Just like in a wired network, a wired network has to have a LAN network have to have a wireless network have a cable, have a switch. In a wireless network, they don't have a cable. What they have is called wireless network card and what access point. So this is an access point for instance. This access point, right, must have a called what a basic set identifier. The base identifier is what identify the access point on the network. So every access point, which is this with an antenna, must have what or a basic service set identifier, just like a switch network. So the switch network is one that every device is connected to be able to have access to the network. The same way, wireless network, all of that to connect to this what or access points for them to be able to what have access to the wireless network. So I would say this access point must have a basic set identifier. That basic set identifier is the hardware address of we call MAC address of what that access point. Right? Now, if we go on, we also have the extended access point too. So extended access point is not measuring. I just say extended basic set identifier is in a network whereby all if you have several all the access point all of them can come together and what be able to what be on one network. So you can all come together, they share the same network. We call it service identifier. I'm going to see it later. They all share the same network. They'll call that on extended base set identifier. So then you also have what called MAC address of AP access point radio. So MAC address, I told you earlier, I said this every access point must have a MAC address. So the MAC address they are different from what we call frequency. So market access point radio, the actually the say their access point radio address is the same unique address for a specific Wi-Fi radio antenna. So a MAC address access point is the hardware address of that MAC address that comes together with the frequency. Every access point must have a frequency. Every access point has a frequency. Is that they operate on 2.4 gigahertz frequency or 5 gigahertz frequency or 6 gigahertz frequency. And remember, you can connect your wired network to your access point. So you can connect your access point. See, these are access points. You can connect your wired network. Or you have to just get a cable and link it to your wired network. So you can do that to your wired switch by switch. It's going to work. Okay, so we're gonna rush this place now. We're gonna rush it. So now what we have here now, I just have this summary of exactly what's going to be here now. All right. So we're not going to, so if you want to have time, look at them the video, fine. But I just have to explain it, just summarize it. So like I was trying to tell you, I told you earlier that access point falls into a standard category called IEEE 802.11b. So you understand? Okay, sorry. IEEE 802.11. So that dot 11, we can have subcategory like level A, level B, level G, level C. We're going to see them. So that means that at every point in time, a company is developing a wireless device. So they must look at a standard they have to develop it onto. So that star must have a frequency and a bandwidth which it can operate. For instance, now take a look. This is the frequency. Now 2.4 is the frequency, right? Now, if you have a frequency of 2.4, it says it has a better propagation. That means it can go, it can transmit at a far rate, it can transmit far. It has fewer channel and it has greater interference. So now there's going to be interference looking at 2.4 gigahertz. Like for instance, now most of our devices we use, they have interferences like your Bluetooth. Bluetooth comes at 2.4, so they usually have interference. Now your microwave, just name them, your washing machine, they use 2.4. Now, but they can I mean better propagation and they can travel large. That's why at times you could just be here and you could have you see another somebody's access point on your somebody's Bluetooth. You could see it because they have better propagation. Anyway, so now we also have a frequency of 5 GHz. So here they have a shorter range. So unlike this on 2.4, they have better propagation and uh, better propagation. But yet now, 5 GHz, they're not going to travel far, just within shorter range, but less congested. You see? Now, take a look now. This is the bandwidth for 11A. So 11 will give you 54 megahertz bandwidth. See? So every standard you see, they have their what? Their frequency and they have their bandwidth. So if you're using 11A, so 11 can give you either 2.4 gigahertz or 5 gigahertz. Then the bandwidth is what 54 megabyte per second bandwidth. That's the rate of which data we're going to transmit. So how fast your data is, how fast your data transfer is, we not rely based on what the standard they are using. Right? Okay. So let's continue. So on and on. So we have see, we have A to the 11B, I told you, and G. I will give you so a network, a wireless network with 802.11b and G has the frequency only. See, 2.4 gigahertz. So this is 11B and 11G. So for 11B and 11G, they use the same frequency. See, same. I'm sorry, they use the same frequency. See, 11B and 11 use same frequency 2.4. Now, what does that tells you? It tells you that every devices, right, that you buy that comes under this standard of 11B and 11G, they can work together. They're compatible. That's what it tells you. There is a problem. They're compatible because they are in the same standard. 11, they are the same standard. So in most of the network device you buy, look at them very well. They have that standard at the back. So the standard means B and G means that they're same standard. They can work together. They're compatible. But there's a problem. The problem is that if the standard is 11B, it will give you what is speeds, a bandwidth of 11 megabyte per second. If the standard is 11G, so it give you a different bandwidth of 54 megabyte per second. So that what I'm seeing here now, right? So what does it tells you? It tells you that the two devices can work excellent. You know, the two devices, since they are 11B, 11G, they can work. But if your network is up, if your network up, if you have a device that work at 11B, and I have a device that work at 11G, by default, the 11B will slow down network, will force every other device to operate at 11B, 11 megabyte per second. That shows when you have 11G on your network, right? You expect your network to be working at what 54 megabytes per second because there's 11B there. Every device will be forced to operate at 11B. So what do you do? Excellent. So what you do, you can disable 11B devices on your network. If you can disable that, which means you can tell your customer to go and get 11G, right, that can give work at 4 megabytes. Because if you don't do that, every device is going to operate at 11B per second. So if you have any question, you just type it on my channel on comment section. I'm going to reply you, right? Okay, so that's the explanation. So also have 11N, the same. So 11N can give you dual band radio, 5 gigahertz, and 2.4 gigabytes. It has its own bandwidth, and on like that. So Wi-Fi 5 and Wi-Fi 5C. So these are Wi-Fi. So Wi-Fi. So on. I'm trying to rush down now because so I'm trying to finish this slide. So this is Wi-Fi 5 and not Wi-Fi 6, right? So we have Wi-Fi 5 can give you 8 to 11 AC. Have this frequency. and on, and Wi-Fi 6 811 AX with this frequency. So it's going to give you either 2.4 or 5 gigahertz frequency. Okay, so now, so that's just a quick explanation, right? So what next now? What next for us now? What next now is that is you're gonna have how you set up your what your wireless network. How do you set it up? So earlier I explained about access points earlier. Now, for the access point you have, the access point are physical devices, physical, sorry, physical. You need to connect into the access point, the software part of it. It has an interface, a GUI interface like this. You need to connect to the access, you need for you to set it up. So that's what you see here now. See, this is the graphical interface of an access point. It could be a wireless router, let's see, wireless LAN installation. So it could be a wireless router or an access point, right? So in wireless networking, you must go and set it up. So the first thing about the wireless networking you want to know about is what called the service set identifier (SID). It's just the name of the network that identify all the what access points in that network, that identify the wireless network. So you give it a name so that everybody that's going to come when you open your phone or devices, and you see when you open your device, for instance, and you go to Wi-Fi, you go to wireless network, you see different network that there. They don't have name. That's what called SID, right? So the SID, like I told you, they must have what a name, right? So all your wireless devices you see now, all of them are connected to that. So how do you access this? How do you access this the wireless network? How do you access it? Again, in our network accession class 2, I'm going to do a training on this, how to access it. I'm going to train it so I can see how to do to access it and configure them. All right. But just know that it's basically through a web application. I could do that. So you can just access the access point with the IP addresses, access it, then you can just go and set it up. Remember, every access point must have what a service set at a name that's identified on the network. All right? Okay. Okay, so we also have called Wi-Fi analyzer. So you can download it on your phone, you can put it on your phone. So it should test signals, the strength of your signal, the wireless network signal, and available wireless network around. What bands are using, what is speed. You see, look at the band, the frequency, 5 look at C. So you want to know what speed are you using and what is the frequency. A Wi-Fi analyzer will do that. It's a software you can download this now. You can just if you are using Windows, just go to download and say Wi-Fi analyzer. You just use it. As you install it, to show you all the wireless network around. This time the signal strength of each of the channel you're using, where you are, your location where you are, and every available access point wireless network around, you're going to tell you. So that's the Wi-Fi analyzer for you, right? So on and on, this is a long range fixed. This is a long range fixed wireless. So long range means you are here and you have another building. You want to connect them and online. So we're going to these are what call most of the time we need ISP to do that for us. Okay. So now we have small network like a wireless network device that we have Bluetooth, and so this is a Bluetooth wireless network. These are Bluetooth devices. I explained earlier. So you can two to Bluetooth can connect just on your Bluetooth, then and you want to transmit data, let your the person you want to transmit also on the Bluetooth, then you can pair the two Bluetooth devices. As soon as you pair them, you're going to see a code that appear like a password. Just put it on the other device and pair them, you can just transmit your file. So that is for two Bluetooth transmission. So Bluetooth means it's a network connectivity too, but wireless, right? So it's a way to transfer information between two devices, between a computer and another device, or your phone or other phone. So you can do that. Then we have what called the radio frequency ID. So in most cases now, if you see those machines, you can go Google and check it. So those machines like the ATM machine, ATM people can hear. So they're usually like that. So they use what called wireless access tags. So they just transmit their signals like radio waves. So those ATM machine you see, POS rather, POS you see, POS machine, you see them like that. They use the radio frequency ID. So they transmit, they have it. they have a wireless access tag, and they also they transmit the radio signal like wave, form of radio wave. So it's a use electromagnetic field to automatically identify and track tags attached to objects. It's a wireless system comprising a radio frequency identifier reader which transmits radio waves and radio tags, which receive the signal and transmit back. So NFC, near field communication. Of course, we all know that. So you just want to pay money with your phone, just to ensure that you have the phone is has the NFC on your phone enabled. If it's enabled, then you can just pay money. So most of us we pay to our phone. We are going to one inside the train. We just tap it and we pay. It's called so your phone must have that. So if you are buying a phone, right, and you want to be able to pay for your phone, ensure the phone has this feature enabled. NFC, contactless payments. If it doesn't have it, then you cannot do contactless payments. So very important. That's why you can shop with your phone, go to supermarket, pay with your phone, go to anywhere and can pay. After buying, you can pay anywhere, go to the train station, use your phone to tap in and tap out. So because your phone has NFC. Okay. Um okay. So that's all for lesson 4. So thank you once again for following us. So watch out for our next video, which is going to be lesson 5. So in our next video, we're going to